Hello students, so today we're going to be talking about categorical variables and the association between them. More specifically, we're going to be looking at two different types of events. The first one we're looking at are conditional probability events. And so if you've looked at the PowerPoint, you know that a conditional probability is the probability of event A occurring given that we know some additional knowledge about an event B. And the notation for that is the probability of event A given event B. And so this line right here just stands for given. So again, this is assuming that we know something about event B already, and we're trying to find the probability of event A. The formula that we get for conditional probability is this right here. So P of A given B is equal to P of A and B all over P of B. So the denominator will always be the probability of the event that we already know. So in this case, since we're given some knowledge about event B already, then the denominator will be probability of event B. So in the next few slides, we look at examples on finding conditional probabilities. In the first one right here, we want to find the probability that a fair six-sided die shows the number 2, given that the number is even already. So here we already have some additional knowledge. We know that the die rolled an even number. Now we want to find the probability that that number is 2. So let's go ahead and look at how we can apply this. Oops, I forgot to erase this. A little quick note before we move on to actually solving the problem. So conditional probability, this is a formula that I have listed in the PowerPoint. So P of A given B is equal to the probability of the intersection all over probability of the given event. So in this case, P of B. If you wish to rewrite it, this is also the equivalent. So probability of event B happening given that A already occurred, that's the same as the intersection, or the probability of the intersection over P of A. So in this case, we use P of A in the denominator because A is our given event now. Also, another important note, if you recall from our AND event section, P of A and B equals P of A times P of B assumes that the two events are independent of each other. For conditional events, the two events are not independent of each other, since event A depends on event B happening already, or event B depends on event A happening already. We're always given some information, and so the two events are not independent. And so whenever you use the conditional formula, it's going to be exactly the way I have written here. P of A and B all over P of B. And so do not write it as, let me actually include it in my note very quick here. So, wrong formula would be something like P of A given B equal P of A times P of B all over P of B. So this would be a wrong formula because again, this part right here is assuming that the two events are independent of each other. In this case, conditional events are not independent of each other, so you cannot partition the numerator into this. And we'll talk about this a little bit more when we get into our independent event section. But please make sure that you do not get into the habit of using this as the numerator. Okay, so now back to our problem. So again, we want to find the probability that a fair six-sided die shows the number 2 given that the number is even. And so for this problem right here, let's go ahead and define what our event A is and what our event B will be. So here, let me go ahead and call 2 my event A, and then event B, let's call that even. So we're trying to find the probability that the number 2 is shown given that the number is already even. So in this case, our given information is that the number is even. So since we have the formula over here, I'm just going to go ahead and plug in 2 for A and even for B. So my formula becomes probability of 2 given that the number is even that's going to be equal to probability of 2 and even all over probability of being even. And so what is the probability of being 2 and even? So if you think about it, the probability of being 2 and even for a die roll is just 1/6. There is only one number out of the 6 that are the number 2 and even. Now probability of being even, we know that that's 3 out of 6. There are 3 numbers out of 6 numbers that are even. After simplifying or after calculating this fraction right here, we should get a final answer of 1/3. So that's saying that the probability that the die shows the number 2, given that the number is even, is 1/3. So if you think this through logically, even numbers, there's only 3 even numbers out of the 6 different outcomes that there are for a single die. And out of those 3 even numbers, there is only one that is the number 2. And so that's 1/3, which agrees with our answer from the formula here. Okay, so my sticky note actually got deleted, so I did add another sticky note right here. This part right here under important note explains why the 2 events are not independent in a little bit more detail. So now moving on to the second example, we want to find the probability that a fair 6-sided die is odd, given that the number is less than 5. So again, I'm going to go ahead and define what my event A and B are. So here, let's say that the event that the number is odd, let's call that event A. And then the event that the number is less than 5, which is our given information, let's call that event B. So again, we can just go ahead and replace A and B with odd and less than 5. So let me move this up here. So the probability of being odd, given that the number is less than 5, that's going to be equal to probability of being odd and less than 5 all over the probability of being less than 5, because this is our given event. And so thinking this through, how many numbers out of the 6 are odd and less than 5? So here we have the number 1, which is odd and less than 5. We also have the number 3, which is odd and less than 5. So that's 2 out of the 6. So the probability of being odd and less than 5 is 2 over 6. Now probability of being less than 5, there are 4 numbers that are less than 5 out of the 6. So the probability of being less than 5 is 4 over 6. After calculating this through, your final answer should be 1/2. So that's saying that the probability of being odd, given that the number is less than 5, is 1/2. And again, we can double check to make sure that our answer makes sense by just thinking it through. So here we're given that the number has to be less than 5. So that means that we're limited down to 1, 2, 3, and 4. Out of these 4 numbers, 1 and 3 are the only numbers that are odd. And so using this logic, we find that 1/2 or 2 out of the 4 numbers are odd, given that the number is less than 5. So again, making sure that you always double check to make sure that your answers make sense. Now the third example is also going to be very similar. Here we want to find the probability that a fair 6-sided die is even, given that the number is greater than 4. So I'm going to go ahead and say that even is my event A, the number is greater than 4, let's call it event B. Now, again, we can just go ahead and plug even and greater than 4 into the formula. So that's going to be probability of being even given that the number is greater than 4. That's going to be equal to probability of even and greater than 4 all over probability of being greater than 4. So out of the 6 numbers, how many are even and greater than 4? There is only one number that is even and greater than 4. So the probability of being even and greater than 4 is 1/6. Now probability of being greater than 4, there are 2 numbers that are greater than 4 out of the 6. So probability of being greater than 4 is 2/6. If you multiply the numerator above and below, you should get 1/2 as your final answer. So that's saying that the probability that the number is even, given that the number is greater than 4, is 1/2. Again, double checking. So here we're given that the number has to be greater than 4. So our outcomes are limited to either 5 or 6. But now we want to find the probability that the number is even. So out of the 2 numbers that we have left right here, there's only one that is even. So 1/2 satisfies the probability that a fair six-sided die is even, given that the number is greater than 4.